Okay, here we are. This is a program that I had for used pages. I was writing a Choose Your Own Adventure book back in the 80s, and you have to jump all over the book because you choose how your main character goes in the adventure. So you're skipping around, so I got this need to try to count from 1 to a certain number. In this program I have it as 50. To skip over the pages you type ahead of time. So if I tell you to count to 5 and skip 4, you do 1, 2, 3, 5 and such. So I'll run it, then I'll explain it. The number set at 50. Okay, type in used pages, type end to end. Okay, I'll erase 1, 2, 3, 4, 1 through 9, and let me do the multiples of 10. Okay, so when I type in end, it'll count 1 to 50, but it'll skip 1 through 9 or 1 through 10, 20, 30, 40, and 50. Okay, there you go. See, it starts at 11, skips 1 through 10. As you see, it has 19, 21 right here. Skips 20, 30, 40, and 50. So I could mark the pages that I used to write in the story, and then do the free pages to direct the reader to for new adventures and stuff. Now, this got a little tricky. I had to think about this for a while. This program is very small, but the concept, there are some involved concepts in here. Now, like I mentioned earlier with subscripts, if you have a list of variables but you don't know how long they're going to be, it is going to be, you have to make subscripts because you're trying to say, I have a list of variables but I don't know how long the list is going to be. That's to be determined, so you have to set it to a variable. So I have here the dimension statement. It's short, DIM is short for dimension statement. The numeric variable C, which is a number variable, to 150, being a safe side. It was originally set to 140 in the program. You count from 1 to 50, and you have here C changes from 1 to 2 to 3 to 4 all the way down to 50, or whatever number you deem fit. So C1 equals 1, C2 equals 2, C3 equals 3, and so on. So this is a little tricky right here. Let C subscript C equal C. Now in variables, you'll have the variable C that equals something. Then you'll have C0 equals something. Then C1 equals something, all the way down. I think the highest subscript the variable can have might be, for Commodore 64, 63,999 or 50,000, or some real high number you don't have to worry about. I've never found the limit as a programmer, so it's pretty high. At least back then it was. So you're having a list of items long as the number that's held by the variable C. You get to determine it. And that's basically all that it is. And you count from 1 to whatever number, skipping over the numbers you typed ahead of time. So it took me a little while to figure out the actual syntax, and the syntax means the way something is written. Let C subscript C equal C, which is pretty cool. And I have the val $, because you're typing in a variable that you're asking for a number, but just in case the user types in text, you have to correct that. There are trickier ways. I could have done a better job right here for a user who really doesn't know what's going on, and they type in like a whole phrase or something. You can explain to the user, that was text, please retype, and so forth. I just didn't need to do that for this program. So now the next thing I want to introduce here is the go-to statement. I have right here, input $. If $. equals end, which I said in the program, type end to end, then go to 65, which means that we're done calculating, we're finished with the list. So 65 means start the list. It prints free pages, counts to 50. If you find a 0 value, that means it's a page that's been used, so you skip over it. And there's another go to 80, which means don't print C subscript C, because that'll be 0. That'll be a waste. And next C, which means go back to this for C equals 1 to 50, which means count to the next number from 1 to 50. So it'll be 2, then it'll be 3, then it'll be 4. Now you have a lot of problems here because you have the go to 80, which means skip over this step 75 and then go to 80. You have the go to 30, which means take another used page input from the user, input a $sign. If a $sign equals in, then go to 65. But if it doesn't, you let the numeric variable a equal value of a $sign. Give this number to C subscript a equals 0. Means you're erasing that number in the count, and go back to 30. Take another input. So you're jumping all over around here. This is called, if I can spell this right, spaghetti code, which means you're jumping all over around. The program works, but you're jumping all over around and it's difficult to follow. Now this is just a few lines of code, 3 through 80. But in the corporate world, the business world, and so forth, you have programs that are hundreds and hundreds of lines of code, and you'll have sections that can get pretty tricky and hard to follow. So the go-to statement is frowned upon. You want to have names of functions and stuff like that, and you call the name of the function, because line numbers get pretty hard to follow if you have to add things in between. If I wanted to add something in between, well, like I did right here, I wanted to make a variable count from C equals 1 to 50. Well, I had to squeeze in 69 because when I typed in 65 and 70, I forgot there was a middle instruction. Luckily, I had some space. Now, if I'm editing the program and I want the computer to do something before 70 but after 69, I cannot do it. I just absolutely cannot do it. Now, I can make a line number 68 do this, and 69 print CC. 69 print CC. And I've thus changed the program. I've got to do what I wanted to do, but see, there's only so far I can keep doing that. I'm going to run out of 60s to rewrite. So something like in when you're doing the programming language C# or something like that, you'll have a function, hello, this will be your variable, and this will be some other number, like that. And somewhere in the program, if you're trying to go to that function, you will just type in something like, if something happens here, then you'll go to the function hello. So therefore you don't need line numbers. You just use the actual words to go to some place in the program, which is pretty cool. So these are like some complex concepts that get pretty involved, that you run into in the software world, trying to make things easy for the user and easy for the programmer, because every time you have to go back and change something in the program, it gets very, very tricky, because you have to basically understand how the entire program works to change something small about it. Otherwise, you're going to have all these errors and mistakes and bugs and stuff, and it's torture. And that about wraps it up.